This will be also streamed online on YouTube. So you can either be in the call or you can see a little bit delayed presentation on YouTube. I just posted in the chat. So let's give people 2 more minutes and we will start. In the meantime, I will test screen share.
Yes, we see it. It's here.
Cool. Thank you for letting me know. So we have now 8 people so far. I will give it 2 more minutes. Okay, so we have around 10 people. I think we can start in 1 minute. I will start actually by introducing our speakers. So we have 2 speakers that will talk today about experience of switching from C# or C++ to Go. First speaker will be František Kaduk. František worked at Skype and Microsoft, where he worked mostly on front end and back end, and in the back end teams. On front end, he worked, for example, on Skype for Windows 8, and on back end, he worked as a technical leader for Skype contacts and Microsoft Teams directory API. He is really C++, C# professional, and he's occasional speaker on conferences. So, for example, .NET Summit or Microsoft Dev Days or Microsoft Fest. Fero joined Outreach last year, and he started to write mostly in the Go. So he will provide you insights about what was his experience and transition from C# to Go. As a second speaker, we will have Alexander Kara. Alexander Kara worked, for example, in Microsoft when he worked on Skype core library written in the C++. And then he moved to Google, where he worked, for example, on YouTube. Most of the time, he was writing code in the C++. Alexander joined us last year in the Outreach. And again, also he writes now mostly in the Go. So he will provide you insights about his experience of switching from C++ to Go. So as I mentioned, we will start with the Fero. Fero, I will stop sharing, and you can go ahead.
Yeah, thank you, Tomasz. Let me start presentation, and I'll start sharing.
We can see your data document for now,
That's interesting. Okay, this is now presentation.
All good.
So thanks so much. So hi everybody. I'd like to welcome you to my session. As Tomasz said, I moved from .NET to Golang sometimes 8 months ago. And during my journey, I experienced several gotchas and aha moments. I made several mistakes, and I would like to share with you a few of them, especially a few which were quite good for me and quite appealing to me. The goal is not to measure which language is better, just to share my personal experience. So let's start the story how I became a Go boy. My name is Fero Kaduk. I'm working at Outreach. You can tweet me on Twitter. I'm blogging time to time on my site. Most of my life I spent programming in C# and just started to write in Go. So hello and defer goodbye. In my journey sharing session, I will talk about language gotchas, runtime gotchas, toolset, and summary. So let's start with language. I started to look at Go during my vacation, and I basically went, to Effective Go website, and then you can basically see and read about Go and directly try some playgrounds and try. And it was really quite simple, but I still was thinking what is this language about. So I then read, Golang spec. And honestly, it took me just not so long time. And guys, honestly, I was working for C# or in C# in .NET. I never read, C# spec. It was crazy long. I don't know how about you, but it was for me too long. Probably only John Skeet read it. So I went through this and read this Golang specification. It looked quite okay. So. But the problem is that I wanted to understand, core idioms of the language, so that when I write the code, it will not look strange to others, especially to veterans in Go, which we have in our company. So, and when I was writing, I was all the time just comparing, C# and .NET, and it's, it's object-oriented programming style to Go. And I've tried basically to apply it all the time. And honestly, this was a mistake. This was wrong. So I can say that, C# is basically, the object-oriented programming language. But Golang, I had the feeling sometimes it's yes, sometimes it's not. It has many commonalities, but also many buts. Go is statically typed language. It's compile safe. It's memory managed programming language. So it's very similar on the surface to C#, but very different in the nature. Go, for example, doesn't have root class. It doesn't have type. Some hierarchy. There is no root class like we have in C#. But it has structs, it has interfaces, it feels quite lightweight, and this was quite appealing to me. So let's look at first construct. So first, when I sit down and try to work on my own, we start to create the object. In C# we know that we are creating a new instance of the object through constructors, and we pass there some parameters or some params. In Golang, it is a little bit different. Golang supports zero-value objects, and zero-value objects are specific. These are basically really zero-value objects. I'll show you on the example. If you have a little bit more complex construct, or if you need to check some invariants when you are creating the new instances, or you want to build some builders and so on, there are constructors like functions. There is the naming convention that this function starts with new and then type name. Then you pass there some arguments and then return this type. And basically, you create probably inside this function the new instance. Comparing to C#, it also supports the params. They are calling the variadic arguments. So let's look at one example. I'm defining struct person and with some fields, and here is an example of the usage. So as I was saying, here is zero-value object creation. So basically, when I'm defining a variable a of type person, by default, compiler creates the code which directly instantiate zero-value object. What does it mean? It means that name will be just empty string, age will be 0, and person, like the children, will basically be empty slice. And then on line 32, I'm just going to manipulate this new instance. I'm going to set the name. If I would do this in C#, I would get directly null reference exception. But this is possible here in Golang, and it is pretty common. Another type of creating new instances is basically just defining person and directly setting up the properties. And the third option is defining this constructor-like function, which is based on the naming convention. It starts with new, and I'm creating basically new object. In this method, usually these methods are more complex. We are checking their invariant and their conditions for name, for and so on. I was trying to find out and understand why it is so. The reason is mostly the simplicity of the language, and Rob Pike, which is basically author of the language, he invented this feature and basically says, make the zero value just useful, So this is one of interesting things which I found in Go. So okay, I was able to create the new objects, but now I want basically to author new structs. In C# we know we have reference types or value types. As I was saying, we have the type hierarchy where a root class is system.object, and it has some basic methods. In Golang, we have only structs and interfaces. And structs, they hold the data, and we are able to define the methods which are working with these structs, or which basically receives these structs and are coupled to the structs. We are able to define how we plan to work with these structs, and this is expressed as data semantic. And we are able to define there by value or by reference, which means when I will be when I will be calling some methods on the struct, and I define data semantic, that every call will be on a copy of the objects, or it will be by ref, which will be the pointer, and which means and this is really basically core idiom of the Go language, and very powerful. But when I was starting to look at it, I didn't understand it very much, and it took me a while, to start to feel this core idiom. And then we have interfaces, and this interface is just set of the method signatures, and basically that's it. As I've told, we don't have there any base class. And when I was trying to understand why it is so, I found on Go blog post, Golang tries to address some fragile base class problem. You can find it on Wikipedia. This is quite a known issue of all languages. And so in Go, we are favoring the composition over the inheritance. And Go adds there a little bit sugar. And I was, this was basically my first thing. It looked to me very strange. And I also blogged about it on my blog site. And let's look at one example. So here on the first lines, I'm defining a struct called square, and I'm defining a method for this square struct to calculate, some area. And then I'm defining, damaged square. And this damaged square is basically, just embedding the square, so composition over the inheritance. So I'm basically just, going to embed the square, and I'm defining there some additional field. And I'm also overriding or defining or overriding in this case, the area method. This embedding means that all the methods which were on the square are visible on damaged square. This is this specific thing for Go, which adds to composition over the inheritance. And now let's look at the usage. So I'm defining a new instance of damaged square, and you already saw it how to create the new instance. And here I'm printing the area and the area. So on line 32, this is damaged area square, and on line 30, I'm also able to look to the square itself. Or what I can do, I can define the interface. I call it shape. And as I told, this is a set of the method signatures. And on line 34, I'm saying that the instance D meets or fulfill all the method sets which are defined on the shape interface. And that's it. And as you can see, I don't need to define on any place that Square implements this interface or the damaged Square implements this interface. But so basically, if the instance meets this interface, or some instance type meets this interface, I can cast, or I can then just assign. And I was trying to find out a little bit more sense of it, and to be honest, there is great talk by Dave Cheney. He's also working for Google about solid Go design. And honestly, this is open-close principle directly in the language. So this is super interesting, honestly, for me. So that we can see Square is closed for modification, but open for extensions, which is, which I show it here on damage Square. So this is quite interesting for me, or was interesting for me. So, okay, I'm able to create the new instances and define new types. Now, okay, I don't want to have everything public and so on, right? So in C# we are able to define what are the public members, protected, private, internal, and so on and so forth. In Go supports public and private. That's it. And this is based on the capitalization of the first letter in the type name. So as you can see, type person with capital P is public, and type person with small p is private. But there is also, the internal, and these are the publics in the internal folder. Go and Go compiler just define some folder structure if you follow it. So there is some standard, which is cool. Then you can get also the internals. There was one gotcha for me, and this was that public methods can return, some private objects. And the C# guys should repeat it and read it several times. For me, it was very interesting. How can the public method return some private objects in C#? I would get some compiler error. So let's look at some small example. For example, here in the log package, I have a with method. And with method returns me a logger instance, and this logger instance is of type the logger, and it is with small l, which means it's private. But this private can have some public methods, and it has some error. So for example, I'm able to get some instance of this object and call the public methods. In C# I wouldn't be able to do this. And what more, I can define interface with, for example, in this sample or demo with one method, and I can just assign the newly created logger some private instance to this public interface, and I can start to use. And then I can start to work with it. This was for me quite interesting and different than in C#. So okay, I was able now to define also the visibilities and so on. And now I would like to bundle it somehow, right? So in C#, as you know, we have a project. They have CSproj folders. Everything is compiled to the assembly. Then assembly, we can basically reference the assemblies, to NuGet or NuGet called sometimes. And these assemblies or these packages are versioned and can be for platforms and so on. In Go, we have a very similar concept. So again, this is feature which is very similar on surface, but different in detail. So Golang has modules and packages. Modules are similar to NuGet packages. They have also versions and so on. But modules contains folders. We call them in Golang, like packages, and they are basically, namespaces in .NET. That's it. And when I'm using the module and referencing some package, which means some namespace, I'm referencing it by using the source code directly. So source code is compiled into my application directly. And I remember the days in C# when I was when you have this issue that you have some project or you have some service and you are using some NuGet package and there is a bug or you want basically to debug it. If you don't have some PDB files, it is very hard. So then you need to use some JetBrains, the compiler and blah blah. Here it is super simple. I was really happy how it is done. And here is some example. So we have a project, we have there one file, Go mode, and here we are defining what packages we want, we require. It's some versions or tags. And here is then when the project is using it, I have all the libraries nearby me, so I can look at them and debug them and so on and go inside. So okay, I was able to do all these things, and now sometimes when I'm calling some service or something, or I do something, we have there some errors. In C#, the errors, usually we throw exception. We throw new exception or retro exception, and then we have try-catch finally blocks, right? In Go, it is different. Go treats the errors as normal return value. And it's called responsibility to check and handle it. To check it and handle it. This was a little bit different, or this was a little bit strange to me, but this is how it is. And there is also a construct for panicking. So the panic, then we have defer and recover, which is similar to try, catch, and finally, but it is really rarely used. It should be used really with caution and not so often. It has its reasons why it's there, but usually we return the errors and check for errors. So okay, I was quite happy with this, but many times we write the asynchronous code. Okay, these days most of the code works just asynchronously. In C#, we have the async await constructs, and basically it is and we have it because we are instructing the compiler to generate the heavy state machinery behind it. And we have there synchronization contexts and async locals. And if we don't want to switch between sync and async, and we want to have purely async path, then we're flooding our code from bottom up with task of T. In Go, we have Go routines. And to be honest, this is for me the most attractive feature I found in Go. And Go routines are very similar to tasks. Difference is that they are built from the beginning in the language. So there is basically natural support in the language, or in the method signatures. So they feed really naturally into this, and we don't have there any some async local state or thread local state. There is thread local state, but it's quite hidden, and there are some places where Google code, like STD libraries, are using it, but not you as a developer will be using it. So, but instead of this, we have a context object or instruct, and we are able to store there the data which we want to propagate to asynchronous flows or Go routines. And we can put there some data or some cancellation tokens and so on and so forth. So, okay, I'm able to write the asynchronous code with Go routines, but there is something more. Quite often, we need to basically give the data to Go routines. And when you have multiple tasks which are accessing same data, you need to have there some synchronization primitives. In Go, this is solved by really another very interesting and second quite attractive feature which come hand in hand with the Go routines, and these are the channels. Rob Pike, same the author of Golang, says don't communicate by sharing memory because of locking and so on. Share the memory by communicating. So and how? By channels. So let's look at the example. So on line 13, at the very top, I'm defining context with the timeout, which this is basically some kind of saying, the cancellation token with timeout. And then I'm creating on line 15 a channel, and there are various types of the channel. Here I'm creating channel C, and on line 22, I am starting new Go routine. For example, this is the Go routine which will go to some database, load the data, and push this data to the channel C. And then another Go routine, this is some next task. This is basically receiving this data. I'm simulating your sleeping, but this second Go routine is loading this or is receiving this data from that previous channel and processing them. Very simple use case, very clean use case, and usage in general of these Go routines and channel. They go really hand in hand. This is really super feature in Go, which I like very much. And again, Rob Pike, channels to orchestrate and mutexes to serialize. And this wouldn't be possible without Go scheduler. We don't have a time to go into the details into the details of the Go scheduler, but this is basically very similar. Or this is basically some machinery behind this, so we don't need to create some async state machines and so on and so forth. So these were the channels and communication. Now we're going to runtime. So language. These were like most nice feature for me in the language. Now let's go to the runtime. Kind of often I was wondering, okay, where the memory is allocated. I'm defining structs and defining data semantic, by value, by ref, and so on. And I was trying to find out where the data are allocated. And a Go compiler analyze your code and decide where to allocate. So you are not in charge of it. The Go compiler will decide. And you can see this is quite interesting because as we move the responsibility for collecting the garbage to garbage collector, here in Go we are going and asking a Go compiler to ask us to basically to ask it, hey, solve for us where to store the data. On this example, I'm on line 12. I'm creating a new small struct object and passing back the reference. In C#, it would go to heap. We have a tool, Go tool, compile -m. This is how we are asking the Go compiler for the escape analysis, where it will be allocated. And we can see that on line 13, a small struct is going to the heap. Fine. Now, if I will remove this Go, no inline line, Go compiler will try, to inline it, and it will find out, hey, this instance is used only in the method, so I will able to basically just allocate it on the stack, not on the heap. And why it is important? Because every allocation on the heap has to be cleaned, and has to be cleaned means some CPU cycles, and it means it has impact on the performance. Sometimes not so much, sometimes can be. And this is, we are coming to the next, this is, garbage collection. In .NET, we have garbage collector, and we are basically allocating stuff on the heap or on the stack. In Go, it's same. Again, It's very similar on surface, but very different in the nature. So let's look at .NET first. In .NET we have small object heap and large object heap, and we have there several. Sorry, here is a mistake. Gen 0, Gen 1, and Gen 2. Generations. We have there several generations of garbage collection. We have there, and runtime has to track also cart table, and we have the different modes with the workstation, server, and so on. In Go, we have single generation GC. And we also split the data to the small object heap and large object heap. A large object heap is over 32 kilobytes. And for small object heap, it's using segmented memory. And the algorithm behind garbage collector, which is powering this garbage collection, is based on trickle algorithm, and it's quite simple. There are plenty of resources on YouTube where you can look at more details, and it is pretty efficient. So this was runtime part. Now we are going to the last tool set part. As I already told about it, the SQL analyzer. This is pretty interesting tool which I'm using. I'm using also the object dump. This is basically very similar to EL DSM, where we can look at the IL code. Here I'm looking at the assembler code, and you are able to basically use navigator. It is not so crazy. We have also GoLint for linting. So basically, we adhere to some coding standards, and also Go formatting. No more wars, tabs, spaces, and so on. There is some standard formatting, and we try to follow it. And really, it simplifies the stuff, the coding. But there is one more thing which I'm using pretty often, and this is tracing and profiling. We use it quite often in Microsoft when we wanted to build performance services. And in .NET, we were using Perfew to capture, some ETW events. On Linux also, there is something similar. And we use also various bunch of profilers, like ANS profilers or Azure profiler, which was really pretty awesome. In Go, Go runtime also provides this information. And there is a package, pprof package from Google, which gives you the possibility to expose this internal information to you. And you can also do tracing through this. And it's really simple. I'm going to show you the tracing. So first the tracing. The tracing, you can ask, the Go service or Go application just to trace some execution, and you can get the full trace, or go to the analysis or blocking profiles, and so on, and so on. And you basically get really big insight what's going on under the hood and where could be the problems. Here is, for example, I took some trace. Here you can see the process where I'm running on 2 cores. You can see here proc 1 and proc 0 and 1. Here are all of the Go routines. Here is, for example, some system calls or network calls and garbage collector, and plus some other stuff. Here I see when the garbage collector ran. Here I see that network finished. So I got stuff from the network, and now another Go routine is going to continue and use this data. This is really detail inside what's going on. This is pretty super awesome from my perspective. And then we have profiling. And profiling is sampled. This is a traditional flame graph, so I can see what's going on in basically the system. When I have some blocking calls or on CPU calls and so on. I can have the same view, just or same data, just different view. I can have also graph and seeing how it is called and where most of the time is spent. And I can also profile the memory. So I see how much object or how many objects are created, how much of space they are using, and so on. Really detailed information. With these tools, you are able to basically see everything what's going inside. Guys, that's all what I wanted to share with you. So let's summarize. Few concepts which are in Go are very similar on surface, but real different in the nature. And me as a guy coming from .NET, I can say that like half of the things are similar and half of the things are different. And generics, I'm using generics, they're coming, they are basically in beta now, and they are coming at the end of the year. We will be able to use it. Just out of the curiosity, I took GitHub statistics, how the language is popular. And we can say this is a GitHub based on the pull requests, and Go is pretty popular and going up. Resources. I'm using most of the time GopherCons or Strange Loop conferences. We have trainings from Ardan Labs. This is a company in the US. We have also some Ardan Labsers, guys from Ardan Labs in outreach. I'm following Go Weekly. And honestly, I'm also learning from the colleagues, especially, or not especially, the colleagues from Seattle. They are basically more mature in Go. They are more time with Go. VK, George, Jared, and also guys from Prague, like Sasha, who is coming after me. So that's all. Thank you very much for watching. Questions?
Thank you, guys. If you have any questions, maybe we can take them after both of the presentation,
okay.
Unless you have something that is very, very urgent and you need to know right away now. So if you have any such questions, please post them in the chat, and we can answer those. If not, then the next presenter is Alexander Sasha Kara, and he will give you more insight about his experience with moving from C++ to Go.
Hello. Let me share my presentation. So this talk, going from C++ to Go, is about my experience when I started coding in Go last year. It's not meant to be a neutral language comparison. It's just a collection of my observations, and it's up to you to draw your conclusions. So I was writing C++ code for over 10 years. In my last job, I was had a side project as a C++ readability reviewer. So I was mentoring people about the common style of C++, like what features to use, what features to avoid. And I was getting quite comfortable in a subset of the language that I was using. It was moving. It was, as the language was evolving, for example, C++11 was a big update. I was learning new things. And very importantly, I was also forgetting or trying to forget old habits, old things. Because C has has dark corners that are better avoided. And therefore, even though I have been working in C++ for a long time, I still don't know the language fully. There are still parts that I don't know. And since I only have less than a year of experience with Go, please take what I say with a grain of salt. So after my personal history, I have some things about the history of the languages of C++ and Go. So curiously, there are some personal overlaps in both languages, or between C and Go. Because Ken Thompson, who is one of the authors of Go, he was also one of the authors of the B language, the predecessor of the C language. And Rob Pike, whom Pharaoh mentioned already, he was, together with Ken Thompson, he was a member of the Unix team, and Unix is also like very closely related to C. but Go is a much younger language. C++ is over 30 years old. It appeared in 1985, and the predecessor C is almost 50 years old. It's like a very old language. And Go appeared a bit more than 10 years ago at Google. And interestingly, it was not the first language that Rob Pike developed at Google. Before that, there was Sozel, which was a quite obscure language for writing data processing pipelines. You declared inputs that you got into the program, and you could fill outputs. And it was the syntax was quite weird, quite unusual, and it was a very special purpose language. But it had quirks. People didn't like it too much, so Go replaced it in the data processing pipelines job. And unlike Sozel, it's a general purpose language. Similarly to C++, it's statically typed, it's compiled, unlike C#. But C++ is a very old, powerful, and complex language which has standards having hundreds of pages. And Go is a more modern language. It has a lot less features. It's lacking generics, although they are coming. It doesn't have operator overloading. It doesn't have distinction between references and pointers. It has much simpler access control, which also Fer talked about. It does some things on that C++ doesn't. It has features above C++. It has garbage collection, which C++ doesn't. But C++ handles this with a different approach. C++ uses libraries to deallocate memory, but you need to be careful. You can make problems if you use row pointers. That's why, for example, at my previous company, we avoided row pointers, and row pointer was a code smell. Instead, we used smart pointers, most commonly unique pointer. And other thing is Go makes some other decisions for the programmers so that they don't have to take care of whether to place the data on stack or on the heap, and has safety features. Like if you need more data on the stack is automatically resized, and all the data is copied, and you can use the new stack. In C++, Stack Overflow is a really hard thing to debug, and maybe that's one of the reasons the Stack Overflow website uses this name. And because Go was created in a time where computers and processors had lots of cores, it has a built-in concurrency. In C++, you can also get concurrency, but it's not in the language, or some parts are in the language recently, like they started trickling in C++ 11 with like memory orderings, etc. And then there are new things happening and appearing, but they are not part of the language, unlike in Go. But Go is not too radical a departure from C. It has some commonalities, and for example, doesn't guarantee concurrency safety, unlike, for example, Rust, which has a borrow checker. And unlike C++, which only focuses very narrowly, as Fer mentioned, Go has a huge ecosystem around it. It has the infrastructure to download dependencies over the web, to build, test. I won't repeat what Fer was talking about. But you can see that, like, if you look at it from the top, you can see the most visible differences, but also most trivial things that don't really matter that much, but that you notice. That you don't have to put semicolons at the end of the lines. You have a different assignment operator if you create a new variable versus if you update an existing one. But unfortunately, with another feature, which is assignment of multiple values, this kind of loses appeal, because what if you have like one old and one new variable? But still, it's it makes it a bit easier to spot new variables, and also it makes it very easy to return errors from the functions, as I will talk about later. Another superficial difference is the switch statement. It's much more powerful in Go. You can switch over strings. You can switch over expressions that are evaluated at runtime, over like return values from a function. And one thing which Go did right, and C++ is very dangerous in, is that in C++ by default, if you don't add a case in the switch with a break, it automatically, the code execution continues on the next case, which is so difficult, so error prone that in a lot of companies there are tools to spot these problems and disallow checking in code which has this. But still, the language didn't remove it and cannot remove it because of backward compatibility. So that's one thing to note. But a more fundamental thing is how resources are cleaned. So C++ uses RAII, resource acquisition is initialization. So on the right side, you can see the C++ example, which in this case is much simpler. Because when you create the file object, whenever it gets out of scope, so at the end of, in this case, at the end of the function, the destructor is called, and the destructor will usually, if the object is well behaving, will free the resources, free memory, and also free the file handle, close the file, etc. In Go, the approach is a bit different. You usually return the value and error separately, and in each case you have to check the error and return from the function that caused it. This is a bit tedious. As you can see, the example is longer. But in C++, in companies that don't use exceptions, which also like some big companies avoid using exceptions, so they had to come up with macros to check the return type and basically do the same as what Go does. And on this slide, you can see another feature of Go, which is the defer statement. And it's also like very unintuitive, or was very unintuitive for me, coming from C++, because it's going to call a function at the end of the current function, not at the end of the scope, but at the end of the current function. And interestingly, it looks like a call to src.close, but it's not a call to src.close. It just would call this function at the end. And it's quite heavily used if you need to free some resources. But C++ has exceptions, uses exceptions for error handling in general. And Go also introduced something along exceptions, which I find is bolted on the language in a quite an interesting way. Go has panic, which terminates the current function and like unwinds the stack. And then in the calling function, you can, in the defer body of the defer function, you can have a recover call, and that catches the panic value as if it was an exception in C++. So it has a similar thing, but it's much less used than in C++. Another thing is, as also Ferro mentioned, is that a lot of things are built in the language in Go, where C++ has everything, not everything, but a lot of things has in the library. So for example, maps, slices, Go routines, channels, all those are part of the language, and also some functions that manipulate those, like make, if you want to create a slice, which is like a resizable array of a certain capacity, you have to use the make method. And it's like a built-in method that you cannot really express in the language. You cannot write it in the language. It's a built-in, and it's like impossible to to emulate. Similar with append. If you want to append to this slide, you call the built-in append function, which is quite different from C++, which has methods on the data type and has its disadvantages. As you can see, it's much more verbose. Some people omit the std namespace, but I added it for like so that we can see how long the writing is. But it has its advantages as well, because you can have different flavors of maps. You can have unordered maps, which are hash tables usually, or ordered maps as implemented as some kind of balanced or unbalanced trees. You can use maps that have value inside the hash table, or maps that store the values somewhere else, etc. Another difference between Go and C++ is, as Ferrum was talking about in detail, there is no inheritance in Go. There is composition, and this is also a big difference in how much you use inheritance in C++. You have to learn a lot.
I'm sorry, I want to ask you, for me the sharing is stuck. I don't know if...
what slide do you see?
Cleaning up after resources, C++ uses, the resource initialization.
Sorry, thank you. Yeah, let me stop and restart the share. Is it moving now?
Yes, it's better.
Yeah, sorry about that. So yeah, this was the example. So now to so maybe let's go back a bit. So this was the example with panic and defer and recover versus C++ way of throwing exceptions. And this is how C++ uses containers, unordered map in this case. So another thing is for the type system, as we talked about, there is no inheritance, there is composition, and it's also one of the traits why Go is more modern, because these days inheritance is thrown upon by many people. So it's like a modern thing to use composition instead of inheritance. And another thing where C++ is different from Go is how it treats types. So interestingly, like C++ has a very strict type system that where types are compatible if they have a common, like custom types, user-defined types, if they have a common base class, or classes are compatible. But in Go, it's enough if they share the same structure. And this is kind of in between C++ and some of the less strict languages where if the object has a method, you can call it, and you don't care about the whole set of methods. So in Go, it's a more strict, because you have to implement an interface like all the methods, but you don't have to have a common base class or declare that you implement the interface. And also there is no automatic conversions in Go. So for example, int and int64 values are not convertible. So as you can see on this slide, this can lead to some problems. If I have a variable of type int64 and I compare it directly with the one, then it's fine. The compiler might tell me that I have to cast it. But if I pass this somewhere where it doesn't have a strict type checking, because it accepts the most general interface, then the first call will succeed, but the second call will fail. because it will not tell you at compile time that 1 and x are of different types, but at runtime it will fail and it will say 1 doesn't equal 1. So this is like one pitfall which is good to remember when you work in Go. But this should be solved with generics, as like Fero said, like he's looking forward to generics. I think this is a good reason for being helpful. For memory management, Fero talked in detail about the garbage collection, that you don't need to free things. This has positive sides, but has also negative sides, that it's harder to keep weak references. Like you keep a reference to something, and if there's memory pressure, you are fine with, or if like nobody uses it, you are fine with it disappearing. But otherwise, you want to keep it in cache. So this is harder to implement in Go, because Go has something like which is called a finalizer, and it's called when the garbage collector wants to free the object, it can provide a finalizer and save itself. So it's possible to use this to pretty much implement what are weak references or weak pointers in C++, but it's a bit more work and it's like bit less intuitive. And I talked about other aspects of memory management, like the compiler decides whether a variable will live on the stack or heap. And this has an advantage that you don't have to think about it too much, and returning by value is recommended. In modern C++, this is the same thing. Returning by value is recommended, but you have to be mindful about potential stack overflow. So you cannot put something too big on the stack, while in Go you can, because the stack will not overflow. So to summarize, with like 3 aspects of the differences between Go and C++. For the speed of development, Go is arguably much faster than C++, because the language is simpler to learn, it has less pitfalls, but it has slightly lower performance and less predictability because of garbage collection pauses. But on the other hand, Go it's harder to create some security problems in Go, because it guards you against buffer overflows, indexing out of bounds, etc. And also, if you use channels, it's easier to write concurrent safe programs, although it's not guaranteed. So my personal pain points for Go is one thing I didn't talk about yet, and that's there's no equivalent of C++ const. Go has a const, but it's just for compile time constants. But C++ has const expr for compile time constants, but it can even return them from a more complex calculation in a function, or like from a template instantiation, etc. And the const, as C++ has it, is very useful, because you immediately know that a variable will not be changed once you look at the line where it's created. For members that are const, it's also very easy to reason about that they won't change after the construction, and you cannot accidentally modify it. So we had a code style that encouraged using const in like as much as you could, because it had like a positive effect. But unfortunately, Go doesn't have this. Also, it's a bit harder to enforce invariants on data structures, because in C++ you can guard your data structure very closely. You can have a constructor which puts it into a valid state, into a consistent state, and all the methods, if they get object in the consistent state, they return an object in the consistent state. So you are sure that it's consistent. In Go, it's you can have like the kind of factory method that's kind of like a constructor, but still you can access all members from inside the package, and the package is usually bigger than what the C++ class is. So you have to be a bit more careful around enforcing invariance, and it also encourages you to make your packages a bit smaller so that you can mentally guard against all the possible cases, all the possible excesses. Yeah, Go doesn't have templates or generics, but they are coming. That's one thing that's going to be solved. It doesn't have operator overloading, for example, or so that if you have types that are naturally addable, where you can add them or subtract them, like time intervals, durations, sets, you have to write functions that do this and call them. And for method overloading, you have to think about the name of a different method that basically does the same as another one, just with different kind of inputs. And other thing which is not really a problem, but this which kind of intellectually bothers me, is that some things are built in and cannot be implemented in a library, like make, new, select, or even the string type, which in C++ is a library object. So thank you for your attention. These are some of the interesting links, and if you have some questions, I would be happy to answer them.
So again, any questions you guys can also post in the chat, and you can also we have live YouTube stream, and you can there you can also ask the questions even longer after this presentation.
I don't have any questions there, but it was awesome. Thank you.
Yeah, definitely. It was awesome, both Fero and Alexander. Thank you so much for that. And we will cut the video and we will share both of those videos on the YouTube. So thank you again for doing this. Okay. In that case.
Thank you, guys. Also, it was a pleasure to hear you guys. Bye.
Okay.
Thank you.
Bye.
Bye.
Bye.